All right, guys. So some people are having a bit of trouble putting all the things together that we're doing. In class, there's an example that you need to do in your notebooks on page 14. But I didn't want to just give you the answers, because if I just tell you the answers to everything, then you won't actually get to struggle with the problem and see if you're doing it right. So what I've done is I've also created this, which has 10 patterns for you to use as examples to practice. And for these, I will provide a key for some of the parts. And I'm also just going to go over one example so that you can see fully what I would expect you to be able to do. So there's some things up here. So like obviously we have the 5 representations, but then there's things wrapped up in that. So from a representation, a concrete one, you need to be able to draw like the next ones in the pattern, right? And these ones are just like block patterns, but when you read something, you need to be able to create the block pattern on your own too. That's just not this one. So like when we did the pool, the koi pond, and when we did the gardens, like from a written scenario, you'd need to be able to do that. Numerical representation, so you want to be able to create a table, because remember, the numerical representation is the numbers, but you organize it in a table. And then identify patterns. Write the verbal representation. For graphical representation, you need to create and then make a dashed line like I did in the day 3 notes, and then use those dashed line to find new values. Okay, and then if your graph doesn't form a line, the dots, then you've done it wrong. Just a little check for you, so you know. Symbolic representation, you need to be able to write it, and then verify that it works, and I'll show you what that means, and then also use this to find new values. And then lastly, again, day 3 notes was all about connecting across the representations and being able to see those similarities or changes in the same one. So we called those change in independent variable and change in dependent variable. And so what you want to be able to do is represent that or find those in every representation except symbolic. Unless, you might use these to find symbolic, but I'm not going to ask you from the symbolic, where is this? But you'll see in the other 4 representations how to do it. So again, there are then several ones that you can try. So I'm just going to do this first one for you. So I've already written or done my little sketch here. So I would recommend, writing it down. And so for concrete model, I'm going to kind of just label the things A, B, C, D, etc. as I go so that you can see what they correspond with on that paper. But you need to be able to do the next ones in the sequence. So what's happening is that it kind of looks like an X. And every time we go up in the figure number, we're adding extra tiles at the end of each leg of the X. So when I go to do the next one, I take this exact one, and then I'm going to add 4 extra squares. So I have my center square, and then here I had 1, 2, 3, so I need to add a 4th one for the next one. So 1, 2, 3, 4, and then that in every direction. And you can tell, it's easier with graph paper, but it doesn't have to be perfect. We're just trying to get across the idea here. 3, 4, and then again for the 5th model, okay, it would be the 4th one, and then I would add 1 square onto the end of each one. So this was 4, 1, 2, 3, 4, so I'm going to do 5 on each leg. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. There we go, Azor. 1, 2, 3, 4, 5. 5. And 1, 2, 3, 4, 5. Okay, there we go. So then what I want to do is create a, I'm actually just going to stick this right under here so I can kind of reference it. So that was A. And then B is to then be able to do the numerical representation. So on these ones, it's kind of nice because one side of the table will always be figure number, and that will be the input. So we have figure, number. And again, that's because we just are given a block pattern. It's abstract. It's not related to like a specific thing like a garden or a pond. Okay, so we have that, and notice I'm going to leave a column for process in the middle. I might not fill it in right away, but I'm going to want that for when I do my symbolic. And then lastly, this is number of blocks or tiles or whatever it happens to be. Okay, so I have 5 here. So 1, 2, 3, 4, 5. And then what you want to do is you can literally, to find these, you can just go and count 1, 2, 3, 4, 5. There's 5 in the first one. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 on that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Be careful not to count that middle one twice, okay? And so on and so forth, and you count and you fill these in. And there you go, okay? So now I have my numerical representation. Remember, it's the numbers themselves. When the figure number is 1, then we get 5. When the figure number is 2, we have 9 blocks, etc. So then C says to write the the verbal representation. So what I want to do is identify the pattern here, and then that will help me write this, because it's talking about the change in relation to each other. So what's happening here is I'm adding 1 to the figure number each time, and in response, I'm actually adding 4, which if you think about it makes sense, because I'm adding those 1 onto each leg of my X, which is like +4. So we have like a little template for this that you can use, or you can do it in your own way, but you say as the independent variable increases by blank, the dependent variable increases or decreases by blank, and that'll always work. So you can just say as the figure number, because that's this, right? Figure number increases by 1, the number of blocks increases by 4. And for what we're doing, for the most part, they've been increasing and increasing on both, but in the future, sometimes this one will decrease or whatever. So keep that in mind, that this word could be decreases if this was minus something, minus something. All right. And now I'm already on part D, which is the graphical representation. So the only thing that's rough about this is that I don't have graph paper here, but that is okay. We're just going to kind of wing it. And I'm just going to do D here. You'll see if when you're doing page 14 in your notebooks, I did include a picture. The picture does not tell you the answer, but it gives you kind of a way to set it up just to kind of organize your work, because otherwise it might be all over the place, and that's a little difficult. Okay, so here's my graph. The independent variable is figure number. The dependent variable is number of blocks. And then here, this only goes up to 5. So 1, 2, 3, 4, 5. And then this goes up to 21. So I might go up by 5, 10, 15, 20. Oh, nope, I might be able to go up by something else. Let's go up by maybe 3s. 3, 6, 9, 12, 15, 18. 21. Let's do it. 3, 6, 9, 12, 15, 18, 21. Okay, just trying to get like a good scale. And I'm doing the best I can. Remember, if this doesn't form a line, 1, you might have made a mistake. 2, your drawing might be really bad. No offense. Hopefully I'm able to kind of pull it off. We'll see. Not your fault necessarily, just a happenstance of not having graph paper. Okay, so figure 1 has 5 blocks. I'm going to go up to almost 6, but not quite. Number 2 has 9 blocks. That's an actual 1, so over 9. 3 has 13, so I'm going to go to 12 and then go slightly past it. 4 has 17, so I'm going to go to almost 18. And then, see, you can see that's kind of a, there we go. 5 is 21. Okay, so as best I can here, I'm going to take this. You can see mine are not all that great, are they? And give myself a dashed line here that goes through the points. Kind of looks like my 9 is off anyway. Like I just did a bad job drawing that one. It should be more like, there we go. Okay, and that's my dashed line. And remember, this is discrete because it's blocks, but I'm putting that dashed line in because I'm going to be able to use that to make predictions, and I'm come back and do that at the end because that's the structure I gave you for your page 14 in your notebook. Okay, so then I'm skipping E and I'm going to go to F, which is write the symbolic representation and then verify that it works. Okay, so writing the symbolic representation essentially is, right, we want the letters. And for this one, I just suggest that you use F to represent figure number and B to represent blocks, okay? I'll tell you on the test what to use, and when you read it, I like to just add them into the bottom of the table, even if I don't do anything with it, because then that reminds me that, oh yeah, F represents figure number, B represents blocks. So, again, I'm skipping E and going to F. So, what I want to do is use a process here, and the way you check is, remember when we filled in a process and then used that to form a symbolic representation, is that when you plug in the figure number, the output should be the number of blocks. If you don't get the right number of blocks for every single one of these, then you know it's wrong, okay? Because your process or representation needs to work for every single one of these. It's supposed to be a general form. So there's 2 ways of doing F. One way is using the process, so I'm going to do this, and then another way is using a formula that will always work, and you're allowed to use it, so I'll show you both ways. So the first one, the way I see it is that there's something that is the same in every single one of these concrete models, and that is the center block. That center block is always the same. So if we thought about the pond problem where the 4 corners is the same, and no matter how big or small the model is, so we did +4. Well, here, this is always the same in every single one, so I'm just going to count that as like a +1. Okay? So if I kind of ignore that while I'm doing the rest of my work, at the end of my process, I can just add that 1 block back. Then from there, I have these 4 legs coming out. So you can see in my first one, it's these 4 legs, okay? And again, feel free to like mark up your test and stuff and work with it or redraw it or whatever. And sometimes I get so messy and then I'm wrong and I have to redo it, and that's okay. Try something, okay? So here I have my 4 legs, and each one has 1, okay? And then if I go to my next one, I have my 4 legs, and each one has 2. Okay, so I'm kind of seeing a pattern that I hope continues, because for my first figure, there's 1 block in each of my groups. In my second figure, there's 2 blocks in each of my groups. In my third, there's, wouldn't you know it, 3. I've kind of made flowers, didn't I? Okay, and then that continues. In the next one, there's 4, and then the next one, there's 5. So the way I see this is that in each of these groups, or in the first one, there's 4 groups of 1 tile or block in each one, plus that middle block, +1. And that's that center block. And if you had a calculator and you put this in, or you followed order of operations, that does equal 5, because 4 times 1 is 4, plus 1 more is 5. Then for my second one, we have 4 groups, which are those legs, with 2 blocks in each one, plus that center block again. So now I have 4 times 2 is 8, plus 1 more is 9. Okay, so things are looking good. So then we'd have 4 times 3, because we have 4 groups with 3 blocks in each for that one, plus the center block. 4 times 4, because we have 4 groups of 4 in the 4th figure, plus the center block. And then last but not least, 4 groups of 5, plus, oops, I was doing so well, 1 for the center block. Okay, and again, all of these work. 4 times 3 is 12, plus 1 more is 13. 4 times 4 is 16, plus 1 more is 17. 4 times 5 is 20, plus 1 more is 21. Great. So then what we do is we keep the things that are the same. So notice we have 4 groups, 4 groups, 4 groups. So we're going to have a 4 here. And then we have that plus 1 for the center tile on each one, so we're going to have a plus 1 here. Now, remember, sometimes it's not identical. Sometimes it might be this number plus 1. Or this number minus 1, but we lucked out and it's identical. It's the exact number. When there's a 1 here, it's a 1 here. When there's a 2 here, it's a 2 here. When there's a 3 here, there's a 3 here. Great. So that means if there's an F here, just put the F in. That's it. Done. Okay? And then that equals B. So then I can take that, and that is my process. B equals, we just kind of put the one thing first for some reason. It's like the mathematical proper way. 4F plus 1. Because it stands for the number of blocks is equal to 4 groups of the figure number, whatever that happens to be. So in this one, 4 groups of 5, plus 1 more, the end. Okay? So that's how you can get it from the process. Now, if you're like, just give me a formula that works every time, Miss Azor. Well, there is a formula that works every time, but you have to memorize it, guys, because you're not supposed to use notes on the test. Okay? If you want to use a formula that works every time, okay, then that formula is that the number of blocks is equal to change in dependent variable over change in independent variable times the independent variable or whatever, the figure number, plus the 0 term. Now, another word for the 0 term is the y-intercept, but either way is fine. So here's the good news. We've actually already identified the independent and dependent variable. We just didn't call it that. So here, the change in the independent variable is in this column because this is the independent column. So this number is my change in independent variable. And over here, this is the change that's occurring in my dependent column, number of blocks. So that is my change in dependent variable. Okay, so I have those already. I'm going to put them in the right spots. So B equals positive 4 over positive 1 times F. And then the 0 term. So the 0 term is, or y-intercept, is when you go backwards so that the independent variable is 0. So here, I'm going to go backwards and subtract 1 to get 0. Well, if I'm going backwards, I need to go backwards on both sides. So if I'm adding 4 as I go down, when I go backwards, I need to subtract 4. 5 minus 4 is 1. So the 0 term is 1, so plus 1. If it's negative, then you can make it minus the number. Okay? So then we just do some cleaning up. 4 divided by 1 is just 4. So B equals 4F plus 1. They're the same. Okay? So this again, this one is no rhyme or reason. Okay? It's just a formula. You have to know the formula and plug the stuff in, but it will work every time. It's related to something else we'll go over this year. This one has to do with the actual process and what's going on. So for me, this one's kind of easier to find, but again, if you're a person who just like wants a formula and you're like, give me a formula, then go for it. So those are the 5 representations: concrete, concrete, numerical, verbal, graphical, symbolic. Now, I'm going to go, I'm still on part F because part F says be able to use, to find new values. And my example was like n equals 15. I didn't end up using n, but what it means is you can come up with these on yourself. That's how you should like kind of practice things essentially. But let's say from part F, the symbolic, we say, well, how many blocks are in figure 37. Okay, just pick a number, just make it up. Okay, so what you need to be able to do is then use this to find the number of blocks. Now, what I'm looking for on the test, so hopefully you're watching this and listening, you bring the formula down, B equals 4F plus 1. The big thing I'm looking for is for you to take this number and plug it into the right spot. Don't just do it on your calculator or in your head and just give me an answer. That's not what I'm looking for because, again, for all I know, Jessica in 7th period texted that to you. I don't know. So I need to see you plug it in. So you plug that in for F because it's the figure number and that's what F represents. So now I have B equals 4 times 37 plus 1. Okay, so then what you want to do is actually calculate this using order of operations. So you do 4 times 37, and we get 148 plus 1, B equals 149. So that means that you have 149 blocks. That's your answer. Okay, now that is one way of doing it, or one question. So I'm going to kind of section this off so that we know it's still in the same group, because that's one way of doing it. But we have two unknowns. We have B and F. So what I want to do now is go the other way and say that we know the number of blocks. So what we're going to do is, let me do a different color so that it looks separate. Which figure number has 61 blocks? Okay, so there we go. Figure number has 61 blocks. So again, I'm going to pull exactly the symbolic, B equals 4F plus 1. And then again, the thing I'm looking for is, can you put this in the correct spot? So that means that you want to take the 61, and since it's number of blocks, put it in for B. 61 equals, and then 4F plus 1. Now, again, I don't expect you to be able to solve this yet. Okay, so you can use guess and check, which means that you can take, I don't know if I have a calculator near me. Let's see. Well, sorry guys. Normally I have a calculator everywhere I go, but not today. Okay, so whatever. You find a calculator, you plug in numbers for F until you get to 61. Okay, I know that it will be higher than 5 because that is 21 blocks. The other way of doing it is to do the reverse of this. So if we were doing order of operations, you would do 4 times F plus 1. Times first, times 4 second, plus 1. Okay, to undo it, you do the exact opposite order, meaning you go up the list and do the opposite of what it says. So to do the opposite, we start at the bottom, plus 1. The opposite of plus 1 is minus 1. So we've undone that, and we get 60 equals 4F. Okay, then we go up the list, which is only one more thing. We do this one next instead. Instead of times 4, we're going to divide by 4. Okay, and oops, Azor. I just wrote 60 again. That should be 60 divided by 4 is 15. Not itself. Whatever. Okay. Sorry, I was thrown off by not having a calculator. But again, do you have to know how to do this? No. You just need to be aha, I found it, y'all. Literally, you can just take your calculator, and again, you should download that calculator on your Chromebook like I told you to, and all you do is go, oh, I'm going to guess figure 10, and you do 4 times 10 plus 1. 41, not high enough, let's go higher. 4 times 20, figure 20 plus 1. Nope, that's too high. Let's try, 12. And you just get closer and closer until you get it, and that's fine. See, too low again, because I need to get 61 blocks. Okay, so I want to see this green line for certain. I want to see you put 61 in for B, but after that, feel free to guess and check. Okay, and again, if you need help downloading that calculator, let me know, but it'll be helpful. So there's that. Sorry, guys. Okay, so that is now part F done, because it says use to find new values, and that's the 2 ways to do that. But remember, I had said we were going to skip E, because E says use the dashed line to find new values. So obviously for the dashed line, I can't do super big numbers because it would be off the graph. But what I could ask is something like, how many blocks in figure 6? Okay, so then what happens is you find 6 on here, and your line should continue. Okay, so you follow 6 up to the line, and then oh my gosh, that was so bad. There we go. Ignore that. There we go, up to the line. And then from there, you want to go over to this axis and find the number that is right here. Okay, so see how I went from, I know the figure number 6, so go up to the dashed line, and then I want to know what the number of blocks is, so then go over to that axis, which again I can tell is crooked. And again, you will have graph paper on the test, so you'll be able to use that. And then you'd go, oh, that number is 25. So then you'd say 25 blocks. And it works in reverse, which means if I give you the blocks first, you start on the blocks and go over to the dashed line and then down. So that's all you're doing, is kind of creating a rectangle, and you can go the opposite directions. Okay, super simple for that one. And then lastly, I said you need to be able to identify the independent the change in the independent variable and the change in the dependent variable in every figure, or in every representation except the, come on, Azor, except the symbolic, okay? So if you notice, I've already done it here and here, okay? So what I'm going to do is assign a color for each, okay? So I'm going to make my independent be blue, and my dependent be pink, my change in, okay? So if I do this right, every time I find the independent variable, it should be +1, the change in the independent variable. Every time I find the change in the dependent variable, it is +4, okay? So now for the concrete model, here, really simple, all I did was, this is the figure number below, you add 1. That is my change in independent variable. So I'm going to circle it or label it. And remember, that triangle just means change in, and then IV is independent variable. Then what I have is these 4 blocks being added, plus 4 blocks. Okay, and that is my change in dependent. Okay, so literally it's that simple. I don't need anything super fancy. I just kind of circled where those 4 blocks are going and wrote plus 4 blocks at the end, and then color coordinated it because I'm going to ask you to color coordinate. Okay, so now I've done it in my concrete. Then it's actually super easy in the verbal because it's just part of the sentence. So as the figure number increases by 1, that is my change in the independent variable, the figure number increasing by 1. So I'm just going to literally highlight that in blue. And then the response is the change in the dependent variable. The number of blocks increases by 4. Highlight it, done. Okay, so not super fancy. And then the last one is we need to look at what's happening on the graph. So what you want to do is pick 2 points in a row. That's kind of the easiest way to do this. And then show what is happening from one point to the next. So to get from like this point to this point, I'm going to go over along this axis, it's parallel. See, I'm going to do plus 1 that way to the right. That's why I'm adding instead of subtracting. And then I need to go up, and I was at 9 and I'm going to 13, so that's going to be plus 4. Ta-da! And there you have it. My change in independent variable, because that will be parallel to the x-axis, which is where the independent variable goes. And then my change in dependent variable, which is parallel, it's going up and down, which is parallel to the y-axis, which is where your dependent variable goes. So there you go. You can see plus 1 in every single one of these models as the change in independent variable, because it's what's increasing by on the independent variable column here. It's what's the figure numbers increasing by. It's written in the statement here, and it is the change side to side in the graph. Then the dependent variable is the change that's happening in the dependent column on the numerical. It's the amount of blocks that's changing in the concrete. Again, it's part of my sentence here for verbal. And then lastly, it's my vertical or up and down change on my graph. And there you have it. That is like the whole gamut of what you would be expected to be able to do. I wasn't able to. This one should be E. There we go. I labeled everything except G. The highlighting for these up here is what G was. And that's it. Again, this doesn't look super nice, but it'll be organized on the test for you, and I give you kind of a template to use for page 14 in your notebooks. Again, you have to remember that I'm also talking you through this, so the video is kind of long, but this is, if you can do this for I would say at least half of these, then you'll be fine on the test. Okay, awesome. Please email me if you have questions, and good luck.